afternoon, everyone.
Good afternoon, Miss.
Is it raining there at your end?
Yes, Miss.
Oo, pwede ang ulan di samon. Kasi bation paguro gani sa mic. Can you share again? So when we speak of process control, I hope you could see that particular part in Canvas where this lesson could be accessed. So we are referring to a subdiscipline of automation that involves the selection and the tailoring of methods for the efficient operation of a chemical process. So we select a particular method, and it's not ending there on the selection, but we also tailor that selected method so as to make it more appropriate to that particular process wherein it's going to be applied to. So it could also be referred to the continuous monitoring of the operation of the plant and the external interventions or the control to guarantee the satisfaction of the operational objectives. So this is how we define process control from two different sources. Now, why is it important that we need to study process control, or specifically to us? So number one on top of the list is safety. So the course process control or process control is existing because safety is foremost in the objective of the operation of a plant. So the safe operation of the plant is the primary concern of any process for that matter. And operating pressures, as an example, temperature, the concentration of chemicals, etc., should be within allowable limits. That's when we speak of safety. Now, when we speak of production specification, it has something to do with the desired amount and the quality of the final products that a particular plant is going to produce. So secondary only would be the quality and the amount, the quantity of the final products that should be produced. Then environmental regulation also takes into account process control, or process control rather also considers adhering to environmental regulations. So various laws may specify that the temperature, the concentration of chemicals and flow rates of the effluents from a particular processing plant should be within certain limits. Okay, and then operational constraints is also something that control considers. So the operation of a plant in this matter must conform with market conditions. So when we speak of conforming with market condition, the availability of the raw material and the demand for the final product has to be considered. That is why also you have what we call as the feasibility study. So it's not just we're going to produce that particular product or products that would be of course used, but of course we have to consider the location where we're going to put up the plant, because we need to look into the availability of the raw material and of course the demand also of the final product in that particular location, or its proximity, the proximity of your location to the areas where your product would be shipped to or sold to. Last is economics. Although we know that economics is also of primary importance when you consider feasibility study, but in terms of prioritizing the needs that process control has to consider, economics is just the fifth. So the operation of the plant should be as economical as possible in its utilization of the raw materials, and not only that, but also energy, capital, and human labor. Thus, it is required that the operating conditions are controlled at given optimum levels of minimum operating cost. So as much as possible, we want to minimize the cost and maximize in the process the profit. So what would be the benefits of process control? So this dictates this 5 here above: safety, production specification, environmental regulation, operational constraints, and economics tells you why process control is important. Now what we have here, if you have process control, this would be the benefit. So if you follow through this, then this would be the benefit that we will be or that the plant or the process facility will enjoy. So enhanced process safety. Of course, it follows that the environmental constraints are satisfied. So there's more efficient use of raw materials and energy. There's increased production level, enhanced product quality, extended equipment life. Okay, this has something to do also with economics, the extended equipment life, and increased profitability. Now this part here is all about process control. So we have started defining the process control, its importance, and the benefits that we will be getting if it's followed through. What carries process control, or who does, or what does, or who enables, or what's the system that does the process control? And that is the control system. So there won't be any process control if there is no system that would go about functioning that particular objective or that particular task. So a control system is a rational arrangement of equipment. So this includes the measuring devices. In process control, we refer to them as sensors. The valves, which are referred to as the final control elements. We're going to learn again on this in detail towards the end term. Then we have the controllers and the computers. And the human intervention. So when we speak of human intervention, that would be the plant designers, the plant operators that will accomplish process control. So the rational arrangements of equipment and human intervention. Rational in the sense, of course, that we're using thinking, we're using the brain, we're using the mind. Now, control system can also be defined as an arrangement of physical components connected or related in such a manner as to command the final control element, direct something to do something, or regulate itself or another system dynamically, meaning it's continuous or actively. So an arrangement of physical components connected such that it commands, direct, or regulate itself or even another system. Now, what are the types of control systems? So we have the closed loop control systems and the open loop control systems. So in the closed loop control systems, the controller, the brain of the system, acts to return the controlled variable to its desired value. So automatically, if the controlled variable deviates from its set value, the controller in itself, the brain of the system, tries to return the value of that particular controlled variable by doing something in the process through the actuation of the final control element. So it actuates the final control element to carry out the task of making sure that your control variable goes back to its set value before the disturbance happen. So because we know, class, that if there aren't any disturbances to a particular system, nothing will happen to the controlled variable. Everything will be in steady state, so there's no point in process control existing. But there is no such thing as steady state. That is why we always have this unsteady state mass balance or unsteady state energy balance. Primarily because maybe for a time it would be steady state, but there are really external disturbances or things that are outside the control of the engineers or the, shall I say, the person that looks after a particular equipment that happens that really requires that there is the existence of the control system. Okay, what about the open loop? So the closed loop control system in here has the controller acting that way. It's not actually the controller that acts, but rather the controller tells the final control element what to do. So you will know later who does the deciding and who does the doing in your control system. Now, the open loop, on the other hand, in here, the measurement signal is disconnected. So the measured or sense value of a process variable is disconnected from the controller. And the controller output in this case is manually adjusted to change the value of the controlled variable. So if something happens to the process, it is expected that your control variable will change its value. So in the case of the open loop system, there is a disconnection between the sensed value and the particular final control element that does the actuation. So what is being done is there's a person, and what we call an operator that manually does it. KT ang control system, hindi naka-automatic. So as you could see here, closed loop is automatic mode, whereas open loop is manual mode. So manual, there is no connection between what was sensed, what was measured, to your brain of the system. So what's happening there is there's an operator that does the adjustment. So the operator sees the corresponding measured value of something, let's say pressure or temperature, then the operator thinks of what's the appropriate thing to do. So he's the one who's deciding for that. Not that there is a particular system that readily regulates itself to make sure that the control variable behaves in the original manner it does before the disturbance happened. So simply, closed loop is automatic mode and open loop is manual mode. Now, what are the common attributes of this control system that does the work of controlling the value or making sure that the value of the control variable stays, even though your system experiences this what we call disturbances or external disturbances specifically? So we have here the common attributes of the control system, or when we speak of attributes, the characteristic of the control system. So a control system has to have this ability to maintain your process variable to at its desired value in spite of disturbances that may be experienced by it. This entire thing that is being described here is what we call as disturbance rejection. So even though your system is subjected to external disturbances, the system in itself, your control system, should have this characteristic to return the controlled variable value to its desired value or to its set value. Another characteristic, it should have the ability to move the process variable from one setting to a new desired setting. So it should have this particular, take note, it should have this particular characteristic that it can move the setting or the value of a particular process variable from one setting to another. The set value that is of a particular process variable should be as changed, or simply put, can be changed by any control system. So there are only two things that this particular control system should have the characteristic of doing. That is, it should be able to reject the effect of external disturbances, or disturbance rejection as described in here. And the other one is the set point tracking. It should be able to change the set point whenever the control variable deviates from the set point. Para maintindihan nyo, kung sa Ilonggo pa, kung may set ikaw nga value sa control variable mo, for example, that is, let's say, 80 degrees Celsius for the temperature, kung mag-deviate na siya sa 80 degrees, dapat ang imo control system, pwede nga ang imo set to nga value nga 80 degrees, kaya nag-change siya, ibalik yaman to, i-change mo man. So for example, nag-set ikaw value 80 degrees Celsius. Pwede mo na siya isla 90 degrees Celsius kung ang imo nga control variable naghimo na 90 degrees. So whatever you should have set there, or whatever was set in your control system, the control system should also have the ability that that particular set value could be changed. And that is what we call a set point tracking. You don't, in this case, it's not the controller that decides what is to be done by the final control element. That way, the set value of the controlled variable could be kept. But rather, since your controlled variable value has changed, what you will do is you will change, or the control system should have this capacity or ability to change what it has set for itself. So isla niya tong set point kay tungod niya nag-change because of the external disturbances. Okay, so these are the important characteristic of a control system. Now, there are three classes of needs that a control system is called to satisfy. So three needs that your control system should satisfy. Excuse me. So number one is suppressing the influence of external disturbances. I think this is self-explanatory. This is usually out of the reach of the operator. Thus, there is a need to introduce a mechanism that could make the proper changes on the process to eliminate the negative impact that such disturbances may have on the desired operation of a plant. Okay, so this since this external disturbances is usually out of the control of the operator, then your system, your control system, should be able to suppress the influence of these external disturbances to your system. Number two need that your control system should address is to ensure that your process would still be stable. So ensure the stability of the process, even if it is experiencing external disturbances. Or your process should have the capacity, or your control system rather, not the process, your control system should have the capability to ensure that even though your process is subjected to external disturbances, it would still be stable. Okay? Or it has the capacity to return the value of the controlled variable to its set value. Then optimization is the last. So optimize the performance of the process. So this is the third need that your control system should address. So the economic objective of the plant must always be maximized. And this is undertaken by the automatic controllers of the plant and its human operator. Okay, as to specific objectives of process control, this one are the importance of process control actually linked to these specific objectives. So actually this you can see here in the importance of process control. So we have here increased product throughput. So when we speak of increased product throughput, it simply is the quantity of the product that is being produced. Increased yield of higher valued products. So meaning if there are byproducts, the value is just minimal. Okay. in decreased energy consumption, decreased pollution, decreased off-spec products, increased safety, extended life of equipment, improved operability, and decreased production labor. Now, what are the design elements of your control system? The control system that carries out the function of making sure that there is control in your process. So we have the control objectives, or we call them the operational objectives, the measurements. So your control system in the first place, by the way, before I go to measurement, your control system in the first place should have a set objective. What is in the first place? It's set objective. A particular control system for one process is different for another process. So this set objective should be specified, or shall I say specified operational objectives. That is, then what are the measurements that are needed? That way your controller will have something to act on. It needs a value for it to act on or decide upon. So this value or values are what we call as measurements. So variables to be measured to monitor the operational performance of your plant. Then what are your manipulated variables? You should know, your control system should know what it needs to manipulate or what should it manipulate. That way your controlled variable should go back to its value if it is disturbed or if it's subjected to an external disturbance. Or what are these manipulated variables? So variables that are used to control the system. What's the control configuration? Anyway, it's in here already. It's the information structure that is used to connect the available measurements to the manipulated variables. So the sensed value or the measured values should be connected to the manipulated variables, because we can only effect a change to our controlled variable if there's a manipulated variable which we can connect to it. What do I mean by that? For example, a very simple example, you have a stirred tank heater. And in that particular stirred tank heater, you want to control, of course, the temperature of the fluid inside the tank. Now, the heating medium of that particular tank is, let's say, steam that enters a coil. So let's say, for example, the set value of your controlled variable has decreased than the set value. Let's say for a set value of 100, ang na-sense nga value lang sa imo nga fluid inside the tank, let's say that's your controlled variable, the temperature is just only 90. So what should be the thing that you will manipulate? That way the temperature of your fluid inside the tank will go back to 100. So in that case, you have to think, paano ko mabalik ang temperatures ng fluid inside the tank to 100 kaya naglubo siya sa 90. So since your heating fluid is steam, your manipulated variable in that case will not be the temperature of the steam, because normally the supply of the steam is fixed in terms of the temperature. What you're going to manipulate is the flow rate of the steam that enters your piping or your heating pipe for your stirred tank heater. That way, there will be a rapid increase of temperature of the fluid inside the tank. So in this case, you are connecting the sensed value or the measured value of the temperature of the fluid in the tank to the flow rate of the steam that is being supplied to your heating, let's say, coils, or your heating coils. That way. So that's just a simple example. So there has to be a connection between the measured values, the sense values, kung damo sila, to the manipulated values. And who does that? So it's the control configuration. The fifth design element for your control system is the brain, which is the controller. So this is the active element that receives the information from the measurements and takes appropriate control actions to adjust the manipulated variable. So kumbaga, it's the controller that dictates your final control element. So I will go back to my example of a fluid or of a stirred tank heater. If you're going to increase the flow rate of the steam that enters the coil, that way the temperature of the fluid inside the tank would go back to 100 because it decreased to 90. Then your controller, the brain of your control system, will be the one to actuate the final control element. And what is the final control element in this case? That would be your control valve. So the control valve in this case, since we want to increase the flow rate, should be open. Should have an increase in the opening. That way there will be a greater flow rate of the heating medium to the coils. That way the temperature of the fluid goes back to 100. So it's the controller that tells or actuates the final control element what to do. It is the controller that decides what is to be done. Okay, so that's it. So these are the 5 elements of your control systems. There's a mention here about the control configuration. So your control configuration could either be a CISO, a single input, single output. This seldom happen unless your system is very simple. Most of the time, the control configuration is MIMO. It's multiple input, multiple output. Now, as to control strategies, we will go back to these two words again, the end term. In the end term, we have the feedback control and we have the feed forward control. So feedback control, I think you know feedbacking. What is feedbacking? You already have something to use that, and then that particular thing to use tells you of what should be done, because there's already something to be acted upon. So the feedback control makes use of the output of the system to influence the input to the same system. So in the case of students, if your score is low and it's given to you, it tells you that you need to study more. So that's feedback. You have something to act on, and that's your score. You have something that was measured already or tested. In the case of feed forward, this is a kind of system that has the objective to measure the disturbances. So it's the disturbances that are being measured and compensate for them before the control variable deviates from the set point. If applied correctly, the control variable will never deviate from the set point. If I would say your feedback, or rather your feed forward control, does not measure the value of the control variable, but rather measures the disturbance in which your system is subjected to. And based on that particular value of the disturbance, it acts in advance of what's going to happen. So that what is going to happen will not happen, it already acts in advance. So it says here, compensate. It compensates in advance before the control variable deviates from the set point. So it does something to the manipulated variable. That way, how do I say this? The expected change to the control variable will not happen because it has already sensed the disturbance in advance and know that if this is the disturbance, this is the expected behavior of the control variable. So wala pa na siya natabo, may ginubra na nga ng system. That way, your control variable will not deviate from its set value. However, feed-forward control is not, shall I say, is not a type of control strategy that, shall I say, is safe for a control system. Kaya ang gwa ni siya, daw gina-anticipate kinangadaan kung ano ang epekto sa disturbance sa control variable. So wala pa na natabo, it does something already in advance. So it's just like compared to a person, bala nga, wala pa gani may natabo, nag-think na siya kung anong matabo, so may ginubra na siya nga daan. So though ang control system in itself will be in constant stress. Because what it does, it already controls it already measures in advance the external disturbances, and in advance already anticipates what's its effect on the value of the control variable. And before na siya mag-change ang values ng control variable, may ginubra na siya nga daan sa manipulated variables para hindi gidya mag-change ang control variable. Oftentimes, the kind of control that is present in the industries is still feedback control or a combination of feedback and feed forward. Okay, so there is always this feedback control that assists or that is being applied together with feed forward control. Now, as to our types of processes, since we'll be testing for stability later on, so we have the stable, or what we call the self-regulating processes. So you have one asterisk here for stable. So meaning if your process is stable, there is no need for external intervention for its stabilization. Pwede ni Ayhan. So your process is said to be stable if even if your process is subjected to an external disturbance, no external intervention is to be done. Wala lang yan sang ubrahon, mabalik lang na siya ya kung ano ang iya nga state before the disturbance happened. So it may be quite difficult to believe, but in a normal scenario, let's say, for example, we'll not think about a process, but there are really processes that are stable. Let alone by itself, it will go back to its steady state condition, even if there's nothing done on the manipulated variable. But on a, shall I say, on a specific example, observable example in real life situation, for example, if you have a spring, and then you try to apply force to your initially undisturbed spring, your spring will elongate. So if you're going to stretch it, it will elongate. If you're going to compress it, of course, it will shorten. But if there's no external intervention done to that spring, for example, I elongated it, I applied an external force to it, and then I release the force that I used to elongate it, standalone, it will go back to its rest state or the state in which it is unstretched. So that's an example of a stable process. If it's likened to a process, wala ka sang may ginobra, pero mabalik lang siya. Basta, of course, ang disturbance, hindi sige man mo gin-apply. It was disturbed, but once the disturbance is already released or once the disturbance already stopped, let alone the system will go back to its original state. That's stable. But when we speak of self-regulating, here the double asterisk, in here the variables are not changing with time. So it's self-regulating if your variables are not changing with time, meaning the time derivatives are all equal to 0. Like dv/dt, ds/dt, if you have such a system in which there's going to be a change in the velocity or a change in the displacement, these two derivatives of s and v with respect to time for self-regulating processes are 0. Okay, so they are self-regulating. The opposite of the stable and the self-regulating processes are the unstable processes. So in here, needed external control is important for your system to go back or to stabilize itself again. So there is to be an external thing to be done. That way your system can go back to its original state. Now, in the design aspect of a control system, we need the input variables, and the input variables are classified either as the manipulated or adjustable variables and the disturbances, or the other term for this is the upset. The disturbances and the upset are those that are outside already of the control of anybody. So any variable that can cause the controlled variable to deviate away from the set point is your disturbance or upset. Whereas the manipulated or adjustable variable is the variable that is used to maintain the controlled variable at its set value or set point. These two are classified as input variables. The stimulus, the excitation or command applied to a control system, which is typically from an external energy source, usually in order to produce a specified response from your control system. So input variables. As for output variables, so we have two also. We have the control variable and the set point. These are output variables. So the actual response obtained from the control system is the output variable. So it may or may not be equal to the specified response implied by the input. So control variable, we know already. This is the very reason why we have process control, because we want to control a certain variable, process variable. So the variable that is to be maintained or controlled at all times. The set point is the desired value of the controlled variable. So these two are considered as output variables. In the end term, you will be given a block diagram that doesn't look like this, but it has transfer functions inside these blocks, transfer functions of these particular elements. And from the transfer function of the elements in here in the blocks, you will have the overall transfer function of the entire system that is being depicted by the block diagram. So this is a block diagram. You have here the controller, you have the heating elements here, you have the clothes here in the case of drying of clothes, and you have the sensor or the measure that measures the moisture content of the clothes. So the sense moisture is returned into the controller. The controller tells your heating element whether there's a need for more energy. That way the clothes will dry up to the desired moisture content, or the controller tells your heating elements to slow down or lessen the amount of heat that is being used to dry the clothes. So this is a feedback control system because you have something that is being sensed, and this sensing is used to manipulate the heat that is being supplied to your clothes so that your clothes will dry up. Okay, a simple block diagram for a simple dryer, clothes dryer. Okay, you also have a block diagram example, but it's very simple than this one in Kauhanor or other books that are available in the internet. So the hardware of process control, so these are the design aspects of process control. So we need the variables here. So when you speak of design aspect, when you speak of the hardware, these are the things that is really comprising your control system. So we have the process, the sensors, the transducers, the transmission lines, the controller, the final control element, and the recording element. So there's 7 of them. This is the hardware for your control system. So the process is the one wherein you're going to control something and that particular thing. So material equipment together with the physical and chemical operation that occurs on it. So we have something to control because of the existence of this particular chemical process. We have the sensors, so they are the one that is used to measure the disturbances and even the controlled output variables. The transducers, these are very important. We will go to this in detail in the end term, converts the measured variable, the measured values to physical quantities. How do I explain this? Our control system, the brain of the control system is, of course, like a computer. It can only process, though it can process or interpret values, but the values that are inputted to your controller is not like if you're sensing temperature, hindi na yang ang imo controller temperature man ang iya i-sense. So it's converted in the form of signals. So the sensed values are to be converted in the form of signals that your controller can understand, because your controller cannot understand temperature, cannot understand pressure. It can only understand voltages, currents, signals, air signals like pneumatic signals. So the thing that converts the sensed value into physical quantities that were given here as an example is what we call as the transducers. So hindi na iya ang control system maka-intindi sang ginasense nga value. It can only understand these electrical signals or physical signals. Who carries or what particular element carries this particular signal? So it's the transmission line. So carry the measurement signal from the measuring device, we call the sensor, to your controller. Then we have the controller. So this receives the information, and the one that decides what action should be taken. It's the brain. It's the brain of your control system, as I have mentioned. The final control element, these are the elements that implements the controller, what the controller decided to do. kumbaga sulugoon sa controller ang final control element. It's the thing that carries out what the controller has decided to do. And then we have the recording elements. The reason why now this is really happening in the industry, a lot of human labor has been replaced by room-sized control panels, is because even if the plant is like a 500 meters away or a kilometer away, in the control room, they can still see the actual values of the variables that a particular equipment has. Why? It's because of these recording elements. So makita na na isang operator nga si evaporator 1 ko amo na niya temperature to ho amo niya pressure because of these display units. So these are equipments or elements or hardwares that provide a visual demonstration of how a chemical process behaves in terms of the values of its process variables. So through these recording elements, they also at the same time record the values that they shall I say, display. So they display the values in some form of monitor. That is why they are called visual demonstration. At the same time, it has also a recording of these visual values. Okay. Now, if we're going to sum up the three basic operations that your control system has to perform through its hardware, to this particular 7 hardwares, it could be memorized as MAD or MDA. MAD, I would tell my student, just remember MAD. So your control system has to measure, it has to decide, and it has to act on what it has decided to do. If you're going to sum up the thing that your control system has to accomplish, that way control is effected on a particular process through the use of these 7 hardwares, it would be this, the MAD, measure, decide, act, or measure, ginusuli ko lang para hapo siya dumdumon, but it's MDA. Okay? You can have this research from Sarkar, and these are the references for this particular module, the first module. And it's downloadable through in here because this one has already been enlarged that way. You can read it in the Canvas itself or in Canvas itself. So this ends the first module for process control. Even in pre-COVID time, I can finish the entire thing in less than an hour. So in our case, we did also in less than an hour because it's all terms. It's all things that only needed to be explained and discussed. Gives you more or less the overview of the importance of the modeling, the mathematical modeling, or the mathematical representation of the physical systems later on that we will be modeling. That way control is effected on a particular process variable. So the reason why we have everything now in the access of even no matter how far they are, they can be accessed easily by a controller or by an operator. It's because it's just in one room, everything in one room, and you can see them, all the process variables that you need to know the values of. It's sad to say you did not have the experience of having to go to a particular, let's say for example, petroleum refinery. Sa una mga graduates makalabot na kami to sa Bataan. We go to Petron. And the control room tells you what's happening in the entire facility. It's just one room. You go there, everything that you need to know about how a particular equipment behaves, you see in just one room. Anyway, probably someday you will also have the chance of seeing how such particular facilities are being controlled in just one room. Okay, that's process control. So without process control, the controls that we need to effect on a particular process variable through monitoring and then the use of the values in the database in monitoring a particular variable, hindi man na siya maubrahan program kung wala ka database of the behavior of your control variable subjected to different types of changes in the input. So with that, the EC is the shall I say, the programmer, the computer programmers, it's their job to think of how they're going to write down the algorithm that will do the controlling of those particular process variables in just one location. You need not really go to a particular equipment, expose yourself to very hot, humid condition just for you to be able to check on a particular process variable and change it to the value that you want it changed to. So only all you need is the control room. You should have a control room wherein everything is being controlled. Okay, this ends the first module. Do you have any questions so far in here? You will have things to answer, I think, sa 19 pa man tong deadline niya, but nonetheless, those questions that you are going to answer is based on something that you're going to read there and something that is being discussed here right now. You have any question here? Okay, none. Sige, sige. So let's have can we have it's 6:21 here. Can we go back 6:30 and I will start with the review of Laplace transformation. Anyway, you have already an idea of Laplace transformation. It's in module 2. It's something that is not very new to you because it was already discussed in your advanced engineering mathematics. I'll go straight there. That way we have already taken everything in advance, and next week there's no more shall I say discussion or synchronous discussion during lab, but rather you will now do exercises related to what we have discussed now. Concerning Laplace transformation specifically. So you can do the exercises next week for such. Okay, so any question before we leave? We'll use the same link. Anyway, we can go back to the same link. If we cannot go back, then I will just give you another link at 6:30. Then we will go to module 2. I will stop sharing. You have any questions? For now, let's have a breather. Then we'll go to straight to module 2. No more questions? Sige. So we'll have a 7-minute break. I will give you a new link na lang in the GC. That way, it will ensure that we can still see each other at 6:30. Okay? So bye for now, class. We'll have a 7-minute break. We'll come back 6:30.